Welcome to the deep dive. Today, we're really focusing on something specific: the configuration, the architecture, and the deployment strategy for generative AI inside Salesforce. And we're targeting the prompt engineering domain for the Agentforce Specialist exam.
Yeah, and this isn't just, an academic exercise.
Uh,
If you're actually preparing for that certification, this one single domain makes up a massive 30% of the total exam weight.
30%, that's huge.
It's huge. And that number tells you everything you need to know about what Salesforce considers the absolute core skill for an Agentforce specialist. It's all about designing, governing, and deploying effective AI with really well-crafted prompts.
Absolutely. So our mission here is to take that 30% and just make it
Right.
crystal clear, really actionable knowledge for you. Because when you look at the whole generative AI architecture in Salesforce, you've got the big LLMs, the large language models, and then the Einstein trust layer wrapping it all up for security.
Right.
The prompt is really the only direct lever that you, as the specialist, can pull.
It is. It's the one thing you control to guide this immense kind of generalized intelligence and make it do a very specific, predictable, and accurate business task.
Right, something that actually fits your workflow.
Exactly. Without a really meticulously designed prompt, the most advanced LLM in the world is just, spitting out text based on global statistics.
hmm
We have to make it useful for us.
And the main tool we use to manage and deploy all of this control is the prompt builder.
Yep. Prompt Builder is Salesforce's low-code interface for exactly this. Its whole reason for being is to make sure that integrating generative AI is secure, it's governed, and it's accessible everywhere on the platform.
Which means you don't have to be a hardcore developer to build some really powerful things.
That's the goal. So mastering Prompt Builder is pretty much the same thing as mastering this entire domain for the exam.
Okay, so let's unpack the basic architecture the prompt builder uses. The source material had this really helpful idea, the recipe metaphor, to define the parts of a prompt template. So what are the three core pieces? The ingredients, guidelines, and grounding.
Right, so we can break down any prompt template into those three logical parts. And they define how the AI acts and what data it's looking at. The first part is the ingredients.
The ingredients.
These are your data merge fields. They're the dynamic inputs. So they pull live, relevant context things like an account name, a case number, a service history directly from your records.
And that can even be complex data, right? Like something you assemble with Apex.
Oh, absolutely. It could be from Apex or even unstructured context that you pull in using a RAG, which is retrieval augmented generation. We'll get more into that later.
So the ingredients are basically the what and the who that the AI needs to be talking about in that specific moment.
Precisely. They give it the immediate factual context. Then the second component is the guidelines.
The instructions.
These are the literal instructions. It's really the art of the ask. They tell the AI its objective, summarize this, critique that, draft an email. They also define the required format, bullet points, JSON, whatever you need, and even the tone,
Formal, cheerful, empathetic.
all of it, and any specific constraints you need to put on it.
Okay, and then the third component, which really separates enterprise AI from, just a generic chatbot, is grounding.
Grounding is maybe the most essential step for reliability. It links those instructions and the dynamic ingredients to your trusted internal company data.
So my CRM data, maybe segments from Data Cloud or official knowledge base documents.
Exactly that. Grounding is the mechanism that stops the AI from just falling back on its general training data, which might be old or just plain wrong for your business. It prevents it from making stuff up.
What we call hallucinating.
Exactly. So Prompt Builder structures these three things: ingredients, guidelines, and post-perk, grounding into a repeatable, manageable template.
That structural foundation is really clear. So now let's get into the template lifecycle itself, because you don't just build one of these and then walk away, right? There are specific steps and choices you have to make for maintenance and deployment.
Absolutely. And the first sort of non-negotiable step is activation. A new or an edited template in Prompt Builder is just a draft. It does nothing. It has zero functional impact until you go in and explicitly activate it. It's a critical safety gate.
So what happens if a template is inactive? What does that look like for a user?
If it's not active, it's basically invisible. Your end users won't see any of the Einstein buttons or icons they're supposed to. And maybe more critically, any downstream automation, like a flow or some Apex code that's supposed to call that template, it just won't be able to find it or run it.
So if you're troubleshooting why a new feature isn't showing up or a flow is breaking,
The very first thing you check, always, is the activation status of that prompt template. It's the simplest fix and the most common problem.
that makes a lot of sense for stability. Now let's dig into the maintenance choices because this is a big one. It has massive implications for the long-term health of your system. When you modify a template, you can either save as a new version or save as a completely new template. What's the practical difference?
This is such a vital architectural decision. If you choose to save as a new version, the underlying unique API name, the system ID that all your automation uses to find that template, it stays exactly the same.
So the ID is static, but the content inside it is updated to the new version.
Exactly. And this is, the path of least resistance for just iterating on something. If you have, say, 50 different flows or Apex classes all pointing to that one API name, they will automatically and seamlessly start using the latest active version of that prompt. You don't have to touch a single one of those flows.
Wow, so it just instantly propagates the update across the entire org?
Decently. It's designed for that kind of seamless update.
That sounds like the obvious choice most of the time. Why would I ever choose to save as a completely new template?
Well, you have to choose that option if you're creating what is fundamentally a new, distinct thing. For instance, maybe you're customizing one of the standard prompts that Salesforce provides that often requires a new reference ID. Or maybe you just need two non-interchangeable templates that do similar but separate jobs.
And the catch is that Salesforce then generates a brand new, unique API name.
Right. And that new ID creates a new deployment burden.
Ah, so the responsibility flips back to the specialist.
Entirely. You then have to go and map out every single dependency. Every flow, every bit of Apex, every Lightning component that was relying on that old template ID, and you have to manually update every single one of them to point to the new ID.
That sounds like a major refactoring task.
It's a full dependency management project. And if you miss even one reference, that piece of automation is either going to fail or maybe worse, it'll just keep using the old, wrong template, potentially creating errors or bad data.
So just to summarize, new version is for iterating on an existing capability, making updates seamless. New template is for creating a brand new, distinct capability that requires a full manual refactoring of all its dependencies.
That's it, exactly. It's the choice between a simple tweak and a full system update. You have to get that right.
Okay. Now that we know how to manage the lifecycle, let's talk about the containers themselves, the
Right.
template types. Because they're not all the same, you have to pick the right one for the job, and they have very different technical requirements and triggers.
Yep. We have three main types to focus on, and each one is designed for a very specific user interaction or integration need. Let's start with the field generation template.
This one is designed to generate or suggest text for a specific field on a record page. The Coral Cloud Resorts example was great for this, using structured data like duration, difficulty, and location to write a marketing description for a travel package.
It's a perfect use case.
Yeah.
It's highly effective for taking structured data and turning it into a fluent narrative text. It saves people a ton of time. But this template type comes with two non-negotiable architectural requirements.
Okay, what are those two requirements?
First, field generation always requires a human in the loop.
Meaning it's never automatic.
Never. The user has to explicitly click the little Einstein generate icon that appears right next to the target field. If you set up a prompt and an agent just saves the record, nothing will happen. The user has to initiate it.
That makes sense from a quality control and security standpoint. You want someone to review the output before it's saved.
For sure. And what's the second, maybe more technical requirement?
The Lightning record page must be using dynamic forms.
Ah, okay. This is a technical dependency.
It is. That little generate button is a specific Lightning Web Component in LWC, and it needs to be placed at the field level in the UI. Dynamic Forms is the framework that lets an admin control the placement of components at that really granular field-by-field level. So if a company built all their record pages using the older traditional page layouts, they can't use field generation.
That's correct. They would have to migrate that page layout to use dynamic forms first. So if you're troubleshooting and that generate button is missing, after you check permissions and activation status, the very next thing you should check is the page structure. Is it using dynamic forms? If not, the button can't even be placed on the page.
I also remember reading that the template has to be directly associated with the target field on the Lightning record page itself. That seems a little redundant if the field is already in the prompt.
It's not redundant, it's actually the final binding step. That association tells the system when the user clicks the icon next to this specific field, run this specific prompt template. If you build the prompt but you forget to make that final association in the UI configuration, the field just stays a normal text field. No AI icon appears.
Got it. Okay, that covers field generation pretty well. Let's move on to the sales email template. Same AI engine underneath, but a different goal and a different trigger.
Right. The sales email template is really tailored for one specific job: drafting personalized sales outreach emails inside Sales Cloud. It's grounded by merging in contact details, account history, maybe product interest to create a really relevant first draft.
And critically, the trigger isn't that little field-level icon.
No, it uses a dedicated button. It's invoked from inside the email composer itself, and it's labeled Draft with Einstein. It's built right into the salesperson's workflow, totally separate from populating fields on a record.
Okay, and now for the most sophisticated one, the Flex template. When is this the only tool for the job?
Flex templates are the heavy lifters, for sure. You need them when your data generation relies on really complex data aggregation, often from multiple, and this is the key part, potentially unrelated Salesforce objects.
Give me an example of that.
Think about generating an account risk summary. You might need data from the standard opportunity object, a custom object you built called service history, and maybe a third custom object that tracks project milestones.
3 different objects that don't have a direct parent-child lookup relationship.
Precisely. Flex templates are built to handle that kind of synthesis of disparate data. And because of that complexity, the way you execute them is fundamentally different.
It's programmatic only.
Correct. You can't trigger a Flex template by a user clicking an icon on a page. They must be invoked programmatically through what's called an invocable action,
So they have to be called from a flow or Apex code.
or even the Connect REST API if you're integrating with an external system. Automation is a requirement to run a Flex template.
And this complexity also creates a specific limitation in the prompt builder interface when it comes to previews.
Yes, that's a great point. The preview button for a Flex template is often grayed out when you first build it. And that's because the system just lacks the runtime context it needs to run a prompt that depends on 3 different objects.
So how do you enable the preview?
To get it to work, the admin has to go in and explicitly select specific related records, like a sample account, a sample contact, and so on, within the prompt builder setup. That selection gives the system the minimum data it needs to run the template and show you a preview of the output.
Okay, so if a specialist is building a flow to call one of these Flex templates, what's the specific flow element they use to pass all that dynamic data, the record ID, other variables from the flow, into the prompt?
When you're integrating that dynamic data from a flow, the designated element to use is the add prompt instructions element.
The add prompt instructions element.
Yep, that element is the connector. It handles all the formatting and makes sure all those dynamic variables from your flow get correctly merged into the ingredients section of the prompt template before it's sent off to the LLM.
We've got the containers and their dependencies down. Now let's talk about what actually goes inside them, the instructions. This is the art of the ask, where how you phrase things really determines whether the whole thing succeeds or fails.
This is absolutely where the specialist earns their stripes. The quality of the prompt is everything. A good prompt has to be clear, it has to be concise, and it needs to be completely unambiguous. You want to minimize any chance that the AI misunderstands what you're asking it to do.
There was a compelling analogy to human cognitive limits, the idea that we can only really process about 7 distinct pieces of information at once. How does that idea apply to designing a prompt?
It's a great analogy. While LLMs aren't humans, the principle highlights the danger of what we call prompt decay. If you try to cram too many complex, nested instructions or contradictory rules into a single prompt, the output quality almost always goes down.
So the model kind of loses track.
It struggles to track all constraints at the same time, yeah, and you end up with confusing or incomplete responses. So simplicity and focus are just key for reliability.
Let's get into some of the specific high-impact techniques to improve quality. We can start with technique 1, role-playing.
Role-playing, or contextual framing, is such a simple but high-return strategy. You just explicitly tell the AI what persona it should adopt. For example, you are a highly experienced technical support agent specializing in enterprise SaaS infrastructure.
Or you are a cheerful but formal customer success manager writing to a new client.
Exactly. And why is that so effective? It instantly narrows the model's focus. It tells it what vocabulary to use, what tone to adopt, what knowledge base to draw from.
It sets the entire context in one sentence.
It does. And tests have shown that just adding that role can increase the perceived usefulness of the output by something like 38%. It's a huge lift for very little effort.
Okay. Technique 2 is few-shot learning, which is about showing, not just telling the AI what you want.
This one is really powerful. It involves embedding 2 or 3 examples of input-output pairs directly into your prompt template. You're not retraining the model, but you are giving it a very focused, in-context example of the exact structure and pattern you expect it to follow.
And there's a really critical constraint here that's easy to miss, related to those dynamic merge fields we talked about.
It is absolutely critical, yes.
Mhm.
These static few-shot examples that you write into the prompt must perfectly mimic the format and the data type that your dynamic merge fields will provide at runtime.
Can you give an example of that?
Sure. Let's say your example shows a currency formatted with a $ and 2 decimal places. But at runtime, your dynamic merge field just provides a raw integer like 5,000. That inconsistency can completely confuse the model, and it'll fail to apply the pattern you wanted. Consistency is everything for pattern recognition.
Got it. Now, what if we have a really big multi-step goal? Something like take a long case transcript, identify the root cause, summarize the resolution, and then draft a customer-facing email.
For something like that, you want to use prompt chaining.
So modularity.
It's about modularity and process management. You break that huge task into a sequence of smaller, focused prompts. Prompt A summarizes the transcript. The output of prompt A becomes the input for prompt B, which identifies the cause. The output of B feeds into prompt C, which drafts the email.
And the main benefit there isn't just quality, it's really about debugging and reliability, especially in an automated system.
100%. If you have one single massive prompt and it fails or it gives you a weird result, trying to figure out why is a nightmare. With chaining, if that final email is nonsense, you can just look at the output of the intermediate steps. Maybe you see the prompt B failed to identify the root cause correctly.
So you know exactly which step, which specific prompt you need to go back and fix.
You can pinpoint the failure. It makes the whole system so much more reliable and easier to maintain.
Okay, building on that, we have technique 4, chain of thought, or COTE-T. This seems essential for tasks that need complex reasoning.
COTE is where you explicitly tell the model to think step by step before providing the final answer. You're forcing it to externalize its reasoning process, to show its work, basically. It stops it from just jumping to a conclusion.
And the material pointed to Apex debugging as a perfect use case for this. How does that structured process actually work in that context?
Well, instead of just giving the AI a chunk of broken code and saying, fix this, a COTE prompt structures the request analytically. You might give it 4 explicit steps. Step 1, determine the precise error and line number. Step 2, analyze the syntax and logic. Step 3, evaluate the code against Salesforce governor limits. And Step 4, suggest corrections and, crucially, explain why you're making each correction based on the previous steps.
And that rigor had real, quantifiable results.
It did. Applying that structured process led to a 46% jump in the accuracy of the solution compared to a simple fix this prompt. It also cut the need for the developer to ask follow-up questions in half because the rationale was already there. It makes the AI a true analytical partner.
Okay, so to make all these great prompts reliable in a production environment, we need to add some clear constraints. We call them guardrails.
Right. Hardening prompts with guardrails is about setting explicit boundaries to limit the AI's creative freedom and make sure the output is safe and predictable. Things like only return output in valid JSON format, or answer the user's question using only the provided knowledge articles and nothing else.
You're putting fences around its playground.
That's a great way to put it. And there's a specific technical formatting requirement for these instructions inside Prompt Builder.
With the triple quotes.
Yes. To make sure the LLM understands that these are hard constraints, the standard practice is to surround your critical instructions and guardrails with triple quotes. That helps it cleanly separate the structural rules from the dynamic content of the prompt.
And finally, what about a backup plan for when a prompt just fails? Maybe it times out, or gets a high toxicity score, or the output is just garbled.
That's where fallback prompts come in. Especially in an automated flow, you have to architect for failure. If your primary complex prompt fails for any reason, the system should automatically trigger a simpler, safer, and faster fallback prompt.
So instead of the whole flow crashing.
Exactly. You get a graceful failure. Maybe it just provides a generic, safe message like, I'm unable to generate a response right now, instead of letting the whole transaction break.
That's a perfect transition to the other side of reliability. Grounding. This is the idea that turns the AI from a general knowledge engine into a trusted, specific enterprise resource.
Grounding is everything. It's the single most critical factor for accuracy. If your AI isn't grounded in your data, it's just going to fall back on its generalized knowledge, which is often out of date, or wrong for your specific policies, or just factually incorrect. Grounding forces it to base its answers on the facts from your trusted internal data sources.
Let's start with the most precise form of grounding, using merge fields with structured CRM data.
Merge fields are your tool for surgical precision. You use them to pull very specific data points: the account manager's name, a contract expiration date, the exact product configuration, directly from your Salesforce objects and into the prompt's context. This is the foundation for really accurate, personalized output.
But there's a well-known and really key limitation here. It's about which related lists are supported for this kind of grounding. The specialist has to know this one.
This is a major exam point. Related lists that rely on what are called polymorphic fields are unsupported for direct merge field grounding.
And a polymorphic field is one that can reference multiple different object types, right?
Exactly. The classic examples are activities, tasks, and events. They use fields like whoid and whated, which can point to a contact, or a lead, or a user.
So why the exclusion? What's the technical reason?
It's because the system can't reliably guarantee the single correct object context at runtime when it's trying to merge that data. The ambiguity of those polymorphic fields just introduces too much risk for unreliability in the context of high-stakes AI grounding. So, activities, tasks, and events are explicitly excluded.
So even though an account's activity history is incredibly valuable context, you have to find another way to get that information into the prompt.
Correct. You can't use a direct merge field from that related list.
Okay, let's look at the next method, record snapshot grounding.
Record snapshot is a different approach. It tries to provide broad context quickly by just grabbing data from the fields that are currently visible on the user's page layout.
It sounds convenient, but I'm guessing it has its own set of restrictions.
It does. For performance, it's generally limited to around 50 fields. And, more importantly, echoing the last point, activities, tasks, and events are also explicitly excluded from record snapshot grounding.
Same reason, I assume. High volume of records and performance costs.
That's the likely reason, yeah. It would be too costly to fetch and process all of that related data for every snapshot.
Okay, beyond those exclusions, what's the most important thing to know about the quality of the data that record snapshot does grab?
It's the filtering. The most critical consideration is that any empty data, so fields that don't have a value, is automatically filtered out before the snapshot is sent to the LLM.
And that's a deliberate choice.
It's a very deliberate design choice to keep the prompt context concise and relevant. You don't want the AI wasting its processing capacity trying to parse a bunch of irrelevant blank fields. It just degrades the quality and speed of the response.
Now, let's talk about an architectural bridge we need to build for integrating data from Data Cloud. We know we can't just use standard merge fields or a record snapshot to pull data directly from a unified Data Cloud object, like a unified individual DMO.
Right. This needs a very specific architectural pattern, because those Data Cloud objects are logically separate from your standard CRM records. The bridge you have to use is called a template-triggered prompt flow.
A template-triggered prompt flow. How does that three-step sequence work?
Okay, so the process starts with the prompt template itself. That template then triggers an integrated flow. Step 2 is the flow doing the work. It goes and fetches the necessary unified data from Data Cloud using special Data Cloud actions or related lists.
And then the crucial third step.
The flow takes that unified data just retrieved and passes it back into the original prompt template for grounding. It's a required data pipeline to get that unified data into the generative AI context.
But Data Cloud can still enrich standard records for use in prompts even without that flow bridge for DMOs. How does that work?
Yes, this is one of its strengths. Data Cloud can unify all sorts of disparate data like web activities and link them back to a standard object like a contact record. Once that unification and linking is done, standard related list merge fields can then pull that enriched data like recent page views or purchase intent signals into a prompt template.
So you get that deep, unified customer context to generate much more relevant insights. Okay, that covers structured data. Let's switch to unstructured data grounding using retrieval augmented generation, or RG. This is the tech that lets the AI reference your knowledge articles, technical manuals, all those internal company documents.
RG is absolutely fundamental when the AI needs to answer questions based on official internal policy. It guarantees the answer comes from your verified company info, not the LLM's generalized knowledge. The tech works by finding small, relevant snippets of text from your documents and injecting them as context for the LLM.
And before RG can even work, what's the prerequisite? What's the very first setup step in Agentforce?
The specialists have to set up the Agentforce data library. That's the configuration screen where you define the source of your unstructured content, whether it's your Salesforce knowledge base, an external SharePoint site, or a specific set of files.
Once the library is defined, the system has to process all that content.
It does. Agentforce then indexes the content. It breaks up the big documents into smaller, logical chunks. And then, crucially, it converts those text chunks into what are called vector embeddings.
So it's turning the meaning of the text into math.
That's a perfect way to describe it. Instead of searching for keywords, the system is now searching a mathematical space for concepts that are contextually similar.
So when a user enters a query that needs RA grounding, how does the system use those vectors to find the right information?
The retriever converts the user's query into its own vector. Then it performs a semantic similarity search against the index of all your document vectors. It finds the top few text chunks that are most contextually relevant, which might just be a few paragraphs.
And that retrieved text is then injected automatically into the prompt template.
Right. It becomes the grounded context, ensuring the LLM uses that specific, trusted information to write its final answer.
Okay, here's a common troubleshooting scenario. I run a prompt, and the retriever pulls back information that's technically correct, but it's totally irrelevant to the user's immediate problem. What's the recommended fix for that?
If the retrieval results are poor or irrelevant, the first thing you should do is define and apply filters on the retriever configuration. You typically do this in Einstein Studio.
And filtering just narrows the scope of the search.
Exactly. You might filter to only include knowledge articles that are currently marked as verified, or maybe only documents related to the specific product line the user is working on. Filtering stops the AI from getting contextually confused by similar but distinct documents.
We've now covered the entire cycle: building templates, crafting instructions, grounding them in data. The final and arguably most important layer is governance, security, and monitoring. Let's start with the fundamental concept here, the shared responsibility model.
Right. This model just defines who is responsible for what. Salesforce is responsible for securing the foundational platform, the infrastructure, and the Einstein trust layer itself. But the customer, meaning the specialist, the admin, the organization, is entirely responsible for securing the implementation.
So, configuring permissions, defining data masking rules, and making sure the prompt design itself is secure.
All of that, you control the governance. Salesforce secures the pipes.
And generative AI brings some specific risks to the table that we have to actively manage. What are the 3 key risks we need to defend against?
Okay, first is prompt injection. This is where a malicious user crafts a prompt to try and trick the AI into ignoring its guardrails or revealing sensitive data. Second is malware resurfacing. This is the risk that the AI could retrieve and process an old file that has malware attached to it somewhere on a record. And third is data leakage, which can happen in complex setups where sensitive data from one trusted context might accidentally get exposed in a less secure context.
The main technological defense against that data exposure, especially preventing sensitive data from even reaching the external LLM provider, is the Einstein trust layer's data masking. How does that work?
It's a multi-step process. First, you, the administrator, configure rules for sensitive data patterns like credit card numbers or customer IDs. Then, when data is being sent to the LLM, but before it leaves the secure Salesforce trust boundary, the trust layer intercepts it. It finds the sensitive data based on your rules and replaces it with synthetic placeholders.
So the real personal identifiable information, the PII, never crosses that line.
Never. The actual sensitive data stays inside Salesforce. Then, when the LLM sends its response back, the trust layer intercepts it again. It demasks the data, swapping the placeholders back out for the original PII, but this only happens inside the secure boundary before the final response is shown to the user.
It's like a mandatory security checkpoint in both directions.
That's a perfect analogy. And beyond just masking, the trust layer provides 2 other critical governance functions: auditability and toxicity scoring. It logs crucial info, giving you an audit trail that proves the data masking worked, which is huge for compliance. It also logs the toxicity score of the response. This is a real-time measure of potentially harmful or biased content. Monitoring that score is essential for safety.
And underneath all of this security is the core policy that gives big companies the confidence to adopt this: zero data retention.
The zero data retention policy is a promise. It guarantees three things. One, no customer data is ever used to train the external LLMs. Two, no customer data is kept outside of your Salesforce org after the request is finished. And three, the external LLM provider can't access your data for any other purpose. It's the ultimate guarantee of data privacy.
Okay, to control who can actually do all these things, we need to get the permissions right. The specialist has to configure 3 specific permission sets for proper governance.
Right. First up is the admin role, the Prompt Template Manager permission set. This is for anyone who needs to create, edit, activate, or to generally manage the prompt templates in Prompt Builder.
And for the end user, the agent who just needs to use the AI features.
That person needs the Prompt Template User permission set. This is mandatory for them to even see and run the active templates. If an agent has the right page layout but they're missing this permission, they won't see the Einstein Generate icon. It controls visibility and execution rights.
And there's a third permission set that's tied to one specific template type.
Correct. The Einstein Sales Emails permission set is required specifically to use the sales email template type from that Draft with Einstein button in the email composer. That permission is tied directly to that one piece of Sales Cloud functionality.
So once everything is deployed and in use, the job shifts to monitoring quality. Beyond just latency and usage stats, what's the most critical metric for gauging the actual value of the AI's output?
The key operational metric you have to monitor is frequent agent editing.
Frequent agent editing.
Yeah. If your monitoring shows that users are constantly rewriting a huge portion of the generated text, say they're fixing 30 to 40% of it every time, that is a massive red flag.
Yeah.
High edit rates mean the AI is generating low quality, unusable, or irrelevant output.
And a high edit rate basically cancels out the business value. The AI is actually creating more work instead of saving time.
Precisely. It signals an immediate need to go back and refactor that prompt. Maybe it needs better grounding, or stricter guardrails, or better few-shot examples. This continuous loop of build, validate, deploy, and monitor is how a specialist makes sure the solution stays high quality and compliant over time.
This has been a really complete deep dive into that 30% of the exam focused on prompt engineering. We started by establishing the prompt as that central control lever, all working within the foundation of the Einstein Trust Layer and Prompt Builder.
We covered those critical lifecycle decisions, really emphasizing that choosing a new version keeps updates seamless, while creating a completely new template forces you into a manual refactoring project across all your flows in Apex.
We detailed the different template types and their non-negotiable requirements. Field generation needing that human-in-the-loop and dynamic forms, flex templates demanding programmatic execution from a flow or Apex, and the separate UI for sales email templates.
And we really dug into the art of the ask, stressing the power of structured reasoning with role-playing, few-shot consistency, prompt chaining for modularity, and of course the huge results from chain of thought for complex things like Apex debugging.
We thoroughly reviewed grounding methods too. That critical exclusion of polymorphic fields like activities and tasks from merge fields, the filtering of empty data and record snapshots, the need for that template-triggered flow for Data Cloud, and the whole RAG process from the data library to using filters for relevance.
And finally, we wrapped with governance. Understanding that shared responsibility model, the trust layer's role in data masking and toxicity scoring, the zero data retention guarantee, and the specific jobs of those 3 required permission sets. The theme throughout is that reliability, security, and quality have to come before speed in the enterprise.
That structural thinking is what really transforms a generalized LLM into a powerful business tool. And speaking of structured reasoning, here's a final thought for you to consider, building directly on that power of chain of thought and prompt chaining.
Think about the most time-consuming, complex, multi-step analysis or triage process that's currently running in your organization. A process that requires a person to manually cross-reference data from 4 different systems, apply some complex logic, and then formulate a decision.
Challenge yourself to break that complex task down into a structured sequence. How could you use prompt chaining to isolate each step? Prompt 1 just gathers the data. Prompt 2, using chain of thought, analyzes that data across those 4 systems step by step, listing its findings. And Prompt 3 drafts the final, reliable, and compliant recommendation based only on the output of that structured analysis in Prompt 2.
That shift from messy manual effort to reliable, automated, structured AI reasoning, that's the real mission of the Agentforce specialist.